right, you guys. So 4.3D lesson. I actually started this one and then I got a phone call, so I had to hang up. So let me kind of pick up from the beginning here. So we are now in word problems that involve inequalities. Okay, that makes evaluating kind of that answer a little bit more difficult. Okay, and you'll see I'll make sure I touch on that as we talk through the answers of this lesson. All right, so a 150-pound person burns 6 calories per minute when walking at a speed of 3.5 miles per hour. While walking, this person eats a treat that has 40 calories. This treat subtracts from the calories burned while walking. How long must the person walk at this speed to burn at least is the key. That tells us we're going to use that symbol there, 190 calories. Okay, so what we don't know in this problem is the time in minutes. So I let my X be time in minutes. And then I do know that I've got 6 calories per minute. So I'm going to multiply the 6 times that X. But then I have to take off the 40 calories that I ate while walking. And that has to be greater than or equal to 190. Okay, so there's my setup. Once you get that, it should be easy peasy. Okay, the solving part shouldn't be the hard part. It's the setup usually that's hard. Okay, all right, so if I add 40 to both sides, I end up with 6x is greater than or equal to 230. 230. Okay, and if I multiply by 1/6, I end up with x is greater than or equal to 38 1/3. Okay, so the answer, how long? This is 38 1/3 minutes. Okay, so the person must walk at least 38 1/3 minutes. Okay, now here's what I need to talk about with this answer. Do not say the person must walk 38 1/3 minutes. Couldn't this person also walk 40 minutes? Couldn't this person also walk an hour? Okay, so these are the key words, at least. By saying at least, you are talking about 38 1/3 and everything bigger. It's very important to understand that concept. No longer is it equal to that one number. Okay. All right. Part B, explain what will happen if the person walks for a longer period of time, a shorter period of time. So longer will burn more than 190 calories. Lesser time, lesser will burn fewer than 190 calories. All right. For I think it's the remaining, let's see. Do we have 8 questions? Yes. Okay, so for the remaining questions, define a variable, write and solve an inequality, write your answer in a complete sentence in the given context. Andy has $550 in his savings account at the beginning of summer. He wants to have at least, keywords there, $200 in the account by the end of summer. He withdraws $25 each week for food, clothes, and movie tickets. How many weeks will his money last? Okay, our unknown is how many weeks his money will last. So we're going to let X, or whatever letter we want, X equal number of weeks money will last. Okay, so withdraw means he takes out $25 a week. Okay, so he's got this $550 in this account, and he takes out $25 per week. So 25 times X would give us that total dollar amount. And he wants that to be at least, so greater than or equal to $200, was it? Yeah. $200 at the end of summer. So there's the equation. Okay, and talking it out helps build it as you kind of read through the words. Okay. All right, now solving it shouldn't be the issue. This 550 needs to get out of there, and it's positive, so we're going to subtract 550 from both sides. When we subtract 550 from both sides, notice that we've got a negative 25x. Don't lose that negative. Is greater than or equal to negative 550 plus 200 would be negative 350. Okay, and we're going to be dividing by a negative. Do you guys remember what happens when you divide by a negative? This thing flips the other way. So negative 350 divided by negative 25 is a positive 14. Okay, we need to interpret this answer. Okay, do not say his money will last for 14 weeks. Okay, his money may last, can last for 10 weeks, 1 week. Okay, so you want to make sure that you address this inequality. And the way that you could say that, here's one way to say that, his money will last at most 14 weeks. Okay, up through 14 weeks. Okay, something along those lines. All right, on vacation, Caitlin wanted to have her hair braided in multiple braids to cover her head. The beautician charges a flat rate of $4 plus 75 cents per braid. She's saved $29 to get braids. How many braids can she get? Okay, so the flat rate is just walking up to this gal and saying, I want my hair in braids. Okay, and then she, on top of that, pays 75 cents per braid. All right, so the question is, how many braids can she get? Let's let X be number of braids she can get. All right, so we've got this $4 plus 75 cents per braid. So wouldn't we multiply the 75 cents times the number of braids that anyone gets? Okay, and that has to be less than or equal to the $29. She only has $29 in her pocket. So she can be equal to 29 or she can be less than that. Okay, here's the inequality we're going to be solving. Subtract 4 to both sides. Divide by the 0.75. So X is less than or equal to, that went in kind of a weird number, 33 1/3. Okay, now here's where it's challenging. You're not going to get 1/3 of a braid. Okay, so she can get she can get 33 braids or fewer. Okay, and that's, I think, how I would say the answer. She can get 33 braids or fewer. Okay, maybe another way to say it is she can get at most 33 braids. Okay, so it's really important to understand your answer is not she can get 33 braids. She may be a little girl. She may be a little girl and not a lot of hair. She may only need 4 braids. Okay, so you need to answer that in the answer. Okay, so 33 she can get 30, she can get 15, she can get 10, she can get 1. Okay. Number 4. Maria is starting a small DVD business online. She makes $2.25 on each DVD that she sells. To start her business, though, she had to invest $750. How many DVDs does she need to sell before she starts to make a profit? Okay, making a profit means that she starts she has more than that 750. She needs to make back that 750 to kind of recoup what she went out to start, and then she starts making a profit. Okay, so at 751 bucks, she's starting to make a profit. Okay, that's what that means. All right, so we are trying to find the number of DVDs she needs to sell. Okay, doesn't it make sense that we would multiply the $225 per DVD times the number of DVDs? And we need that to be greater than the 750 bucks that she's already out. That's the equation, or I should say that's the inequality. Okay, now to solve that, we're dividing by the 2.25 on both sides. And this comes out to be, and you please use a calculator with these yucky numbers. This comes out to be 333 and a third. X has to be more than that. Okay, now let's interpret that for the answer. You can't sell a third of a DVD, okay? And if you have to be more than this, do you think the answer is 333? No, because that's less than this. So doesn't she have to sell a minimum of 334 DVDs? She needs to sell a minimum. Okay, that takes care of the inequality. A minimum of 334 DVDs. Okay, wouldn't it be great if she sold 1,000 of them? And doesn't this say she can sell 1,000? Okay, that's important to understand. All right, the community pool, number 5, charges a flat rate of 50 bucks for a birthday party plus $2.50 for each person. Deborah can't spend more than 100 bucks. How many friends can she invite? All right, well, we don't know the number of friends. Number of friends can invite. All right, so we've got this $50 flat fee coming in plus $2.50 per friend you invite. And you cannot spend more than 100. You can spend 100, so it has to be less than or equal to 100. That says I can spend 100 or less. Okay, there's our inequality. Once you get that, I think it's easy to solve. Okay, and then it comes hard at the very end where you have to interpret what that means with this context. So 2.50x is less than or equal to 50. Divided by that 2.50. That goes a nice even 20 times. Okay, now for the answer. Do not just say she can invite 20 friends. Okay, maybe she only wants to invite 10. Okay, maybe she only has 5 that she really is like, yeah, those are the 5 I'm inviting. Okay, so the way that we can say that is she can invite up to, that takes care of 20 friends. That takes care of that inequality, the up to. Okay. Jacques has a prepaid phone plan. He has 45 bucks to spend and each minute costs 40 cents. What is the most minutes he can buy? So X equals the number of minutes. All right, 40 cents. 40 cents a minute. And then it has to be less than or equal to this 45 bucks that he has to spend. He can spend 45 or less. He doesn't have more than that. Okay, so there's our inequality. Divide by the 0.40. And that comes out to be this ugly 112.5. Okay, do you think any company is going to give you a half of a minute? Okay, you have to be less than or equal to that. So your answer would be he can buy as many as, okay, and that takes care of that inequality, 112 minutes. Okay, a couple more left on the back page, 7 and 8. All right, and at any time you can pause and try. Okay, these are all kind of a little bit different. You just have to kind of read the words and set it up according to what it says. Okay, number 7, Harry wants to download some songs to his iPod player. If he gets a $20 gift card for his birthday and each song costs 90 cents, at most, how many songs can he download? Okay, X equal number songs can download. All right, so 90 cents per song. We need to multiply those together to see how much it costs for however many songs he downloads. Okay. All right, that has to be less than or equal to his $20 gift card. He can spend $20 or less. He doesn't have more than 20. That's what that inequality says. We divide by the 0.90. It comes out to this yucky, I think it's a 22.2222 repeating is what you'd see in your calculator. Okay, less than or equal to, okay, you're not going to get this 0.2 repeating of a song. Less than or equal to this, you guys coming up with 22? He can download a maximum. Okay, that takes care of that. A maximum of 22 songs. Okay, maybe he doesn't want to do it all at once and he only does 10 of them right now. Okay, so 22 maximum. Last problem, number 8. You have $10 to spend at the school carnival. If each game costs 25 cents, how many games can you play? X equal number of games can play. All right, so 25 cents, 0.25x, and we have cannot spend more than $10. So we can spend $10 or anything less. So that comes out to a nice even 40. Do not say you can play 40 games. What if you get tired and want to leave after 20? Okay. All right, so he can play. I don't know why I said it was a he. He can play at most. That takes care of that symbol, at most 40 games. Okay, so what you should have gotten out of this lesson was how to do this kind of 4-step process. Stating a variable, defining a variable, writing an inequality, solving an inequality, and writing your answer in a sentence for the context of the problem. Okay, so very important to understand how to interpret the answer when it's an inequality. It's much trickier than if this was an equal sign. Okay. All right, thanks guys.